Hello to all my integrated math students out there. This is Mr. Schaub. This is your video lesson for section 4.1, Measures of Central Tendency. All right, got some good news for you, people. This is the second to last lesson you're going to have for the year. This is a review. I know you've covered this in either 7th or 8th grade. You probably called it mean, median, and mode. But we're going to call it measures of central tendency because that's the umbrella term for all of those different terms, and I'll discuss that a little bit more as we get into it here. But yes, if you remember mean, median, mode, okay, I got a little meme here for you just to get us started. This is the one time it's okay to be mean girls. So obviously we're mercy girls. We're never going to be actually mean to somebody else. But it's a play on words, all right? If you know how to calculate the mean, you can be a mean girl too. On Wednesdays. Well, now that we're at home, I always wear pink on Wednesdays. I hope you all do too. But yeah, so that's what we're learning about today. Got my cool lightsaber here to help me. So what we're looking at for the rest of the year. Remember, you're not going to be tested over section 4.1 and section 4.2. Next week we're going to cover a little bit about probability. So thought I'd tack these lessons on at the end of the year since we had 2 weeks here. These are important topics, and definitely if you ever get into a statistics class, you'll talk more about central tendency and probability for sure. But these are really important because these come up all the time. So we're going to talk about some real world applications where finding the central tendency of some data can help us, come up with some conclusions and make some predictions about what might happen in the future and what we can expect. So we'll go ahead and get started as Regina George just sits and watches us from her perch. So I'm going to go through the definitions with you, and I got a little example here that I'm going to go through. You know what? It's a great idea to write this down too. I know I kind of jammed this stuff in here, but the great thing about taking notes on Notability is you can write something and you can shrink it down as small as you want it and move it all around and get it to where it looks good still. So don't be afraid to use that feature. And if you just want to write down the definitions and you don't want to write down this example about water consumption, that's okay too. These are your notes. We're going to go through plenty of examples after this. But I just want to kind of give you a feel for what these mean in the context of a problem and how they differ and why they're all important. Okay, so first thing is data. Our first definition, data is facts or statistics, often a collection of numeric values, which just means a collection of numbers used to help us learn about something. Okay, so for example, the mini lesson here, the mini example I have is water consumption per day. So you probably heard before adults, and so we'll just assume this is for an adult here. Adults are supposed to consume 64 fluid ounces of water a day. That's 8 cups of water. All right, so if let's say you're not sure if you're meeting that quota or not, and for the sake of argument, we're saying you're all adults. I think you all act like adults, so let's just call you adults. So you record your water consumption for every day for a week, 7 days, and this is what you come up with. All right, so this is how much water in fluid ounces you drank on all those 7 days. You write them down, you record them. That's data, okay? So it doesn't have to be something fancy. You don't have to have a million data values to make it meaningful. You just write down something that you do for a week, boom, you've got a set of data. Okay, so this is how much water we've been drinking. All right, so the first definition is the mean. The mean is the average. I know you've heard the word average before in your life. So that's probably what you're used to. Mean means the same thing. You add up all the values and divide by how many values there are. So let's take a look. If our data is up here, we're just going to take all 7 of those numbers, we're going to add them up, and then we divide the entire thing by 7. So this is a calculator job. Obviously, do not try and do this without a calculator. Just throw it in there. Make sure you're getting it right. And if we find the mean, the mean is 59.6 fluid ounces per day. So the whole purpose of central tendency is to find the center of the data. Like, what is the data trending towards? Where is the center of that data? And that's why that word is so important there in measures of central tendency. Okay, from looking at these numbers, do we really know if we're drinking 64 ounces per day? No, not really. Some of them are above, some are below. We could maybe make a guess, but we don't know. The mean tells us how much we're drinking per day. So if we find the mean, it tells us, okay, we're drinking 59.6 fluid ounces per day. So our average value is a little bit low. We're about 5 ounces low. We need to drink a little bit more water if we want to hit that goal. All right, so just it doesn't have to be anything fancy. That's how you find the mean, and that's what the mean can tell us. Okay, next is the median, and this is a different measure of central tendency. It comes into play when outliers are involved, and we'll talk about outliers in here in a bit. You can see it at the bottom of the page. Outliers can throw off the mean, and I'll explain why. But first, let's figure out how to calculate the median. This is a lot easier than the mean. The mean, you got to add up a bunch of numbers, make sure you divide by how many there are, get that right. The median, all you got to do is put them in order. So you can see I double underline that. It's really, really important. If you're going to find the median, you got to have the points in order. So let me show you why. Because in order, you're looking for the middle value. The median is the middle value. We don't really care. We're not taking into account any of the other values in the data. We're just looking at the one in the middle. So if I get my laser pointer out here, you can see we have 7 data values, 66 is in the middle because we have to count in 3 to get there from the left side. We have to count in 3 to get there from the right side. So our median is 66. So these are both measures of the center of the data, but they're a little bit different. And I will explain why in a second when we talk about outliers. All right, up next. So mode is the third measure of central tendency. This is the easiest one to work with for sure, but we don't use it a whole lot. So it's a value that occurs most frequently. So whatever number occurs the most in your data, that's your mode. Okay, so in this case, it says there can be multiple modes, there can be no mode. If nothing repeats, you have no mode. Okay, it's not like you count all 7 of these numbers as modes because they all occur one time. They have to occur multiple times in the data. If that doesn't happen, then you have no mode. So in this example that I'm talking about with water consumption, you do not have a mode in this case. All right, so mode's really easy to work with. There's actually no calculation at all. You just look for the data value that occurs the most, and that's your mode. All right, and then finally range. This is a measure of spread. This is not a measure of central tendency. Only mean, median, mode, the 3 that start with M, are measures of central tendency, which also starts with an M. So that's pretty cool. But the range tells you what the spread in the data is. So basically, we find that by finding the difference of the highest and lowest data values. So you can see what I did here. The highest value we had in all 7 of these values was 81. The lowest was 18. So all we have to do is subtract those. Remember, difference means the answer to a subtraction problem. So we get 63. So that means there's a range of 63 fluid ounces, which means anywhere between 18 and 81 are where the data values lie. Okay, so that kind of gives you a lower bound and an upper bound. It tells you how spread out the data values are. All right, and that's important too, especially when you get into higher statistics classes. Our last definition is outlier. So what an outlier is a data value that's considered to be far above or far below the rest of the data. So if you look at our data, you can see there is an outlier here. All of the values tend to be around the 50s, 60s, 70s, 80s, and then we got this guy, 18. That must have been a bad day for you. If this is your week, you only had 18 ounces of water that day, you were probably tired, achy, cranky. That was probably a bad day, but that is an outlier. That is unusual for really anybody, but it happens. So that's why there's a difference between the mean and the median. Usually these two guys are pretty close. They're both measures of center, so typically they both should give you about the same value. But outliers can change that. The reason being is we're adding all these up. If this were a normal number like 50 or 60, this total on top would be a lot higher, and then when we divide it by 7, we get an answer that's closer to what the normal value would be, what the true average is. Okay, but because it's an outlier, this top value is a lot less than it should be. That throws this off. When we divide a smaller number by 7, that's going to throw this off. Median is important because when you have an outlier, it doesn't really take that into effect. See, the 18 is just over here by itself. It doesn't get factored into the median at all. We're only looking at the center data value or the 2 center data values if there's an even number. But the 66 the median is completely unaffected by any outliers because it doesn't matter what this could be a 0. This 81 could be a 430 if you drank that much water in one day. It wouldn't matter. It doesn't change the median. The median's always going to be 66. All right, so that's just a little intro. If you forgot what this was all about, now you know. Let's look at a couple examples. I kind of took it easy on you guys. You're welcome, because I kind of put the notes and the practice problems all together. So if you're watching this video, sorry, I hope I'm not making you nauseous or anything, but you just have a couple practice problems down here. Of course, we're going to do all these together, but I do want you to try number 5, A and B on your own. All right, that's your practice section. And then, of course, we'll talk about a couple of these here in a second to get you started on that application. But the first big example here, let's just jump right into it. All right, and this example deals with probably one of the most important things in some of your lives, winning an argument with a sibling. Okay, so what we're talking about here is Sydney and Rachel. We got these two sisters. They are arguing over who is the better math student. Since they're in different grades and taking different courses, they decide to compare their math test scores. Their scores are shown in the table below. So you can see we got 6 test scores for Sydney up top in that first row, 6 scores for Rachel. Get my laser pointer out here. Here they are. All right, so that's what they scored on all these tests. So it says find the mean, median, and mode for Sydney and Rachel. And range. We're going to find the range too. So I need to throw that in there. Okay, so let's take a look. So remember, calculating the only thing that really needs to be calculated is the mean. The median and mode are a little bit easier to find, but remember, with the mean, it's a good idea to write this out, people. All right, don't just assume that you're going to type it into the calculator correctly. It really helps when you can look at it, make sure what you wrote down matches what's on the calculator screen. All right, we don't want to make mistakes like that. So all we do for Sydney in the left box, we just add up those 6 scores. And because there are 6 scores, we divide that sum by 6. So what we get on top is 516 divided by 6, and when we do that, we get 86. All right, and of course, if you get a decimal, you just want to round that off. We know we're approximating the average anyway, so feel free to round it off to the nearest tenth, whatever you want to do. All right, so her mean score is 86. What does that mean? It means on average she gets a grade of 86 on her tests. Okay, so her median is, so remember, the first thing you want to do with median is put them in order from least to greatest. So we have 71, 82, 82, 88, 94, and 99. They are in order. You can see we're going to have a mode here, but that's what we get. So with an even number, and I put this over here too. Let me erase this. All right, so over on the side here, helpful hint, evens and odds. If you have an odd number of what that we did up at the previous problem, if you have an odd number of data values, there's only going to be one median in the middle. But if you have an even number of data values like we do here, we have 6 data values. So there's 3 on this half and 3 on this half. There's not a single value in the middle. There's actually 2 values in the middle. So you want to do what we call split the middle, which means you're going to take the middle 2 values and you're going to find the average of them. So basically you add them up, divide by 2, and that will give you the number that's directly in between them. Okay, so if you think about it, that makes sense. 85 is directly between 88 and 82 because it's 3 away from both of them. So our median, even though 85 is not a data value, 85 is our median in this problem. So that can happen sometimes when you have it'll happen every time when you have an even number of data values. You have to split the middle. All right, find the average of the 2 terms in the middle. Okay, and then finally, mode is super easy, especially when they're in order. You just look and see which value occurs most. And again, if no value occurs twice, then you have no mode. If, let's say we had 82 and 82 and 88 and 88, okay, they both occur twice, then you would have 2 modes. All right, so it's pretty simple. You just got to know the rules there. And then the range is 28. And again, I don't have any work shown, bad teacher, but it means you take the 99 is the biggest score, you take the 71, you subtract them. All right, so that the range of her scores was 28 percentage points, basically. All right, from a 71 to a 99. That's what her range was. All right, so here's what I want you to do. Pause the video, try and find the mean, median, mode, and range for Rachel in the second. Remember, that's all the values from the second row of this table up here. And then do it on your own. Pause the video, come back. I'll give you a second to do that. And then see if you got all those answers right. Okay, and then I also want you to think about this answer down here. I didn't write an answer here on purpose. I want you to think about it. So pause the video, come back. If you've got, once you answer this on your packet and you answer this, we'll talk about it a little bit and you can see what the answers are. All right, ready, pause, and go. Okay, hopefully you pause that video. You got it done now. Check out the answers here. For Rachel, you should have got a mean of 84.3. For the median, again, we have to split the middle here. Her two middle terms are 87 and 89. So what's the number that's right between 87 and 89? To find that out, you add them and divide by 2, and you get 88. There's no test scores that are repeated, no numbers repeated, so we have no mode. And then the range is 96 minus 56 gives us a range of 40. So hopefully you got all that right. Okay, now to answer this, it's I just want to kind of discuss it on this video, and you can think about it, but I do want you to come up with your own answer to this question. And I will be reading it to see what you said, all right? And I expect a different answer from everybody, okay? So that's why I didn't put anything on my notes, and I don't want to see 8 girls saying the exact same thing. All right, so think about it on your own and come up with an answer. But so remember, these measures here are supposed to measure their central tendencies. All right, so what they tend to do all the time. Like this is the average, this is the median. All right, and again, mode doesn't really help us in this situation. Mode is helpful sometimes, but not really here. It doesn't matter. If you score the same score on a test twice, it doesn't mean you're a better math student. So the mode really doesn't matter, but I want us to compare the means for the two girls and the medians. So Sydney has a higher mean, which means on average, she gets a higher score than Rachel. However, Rachel has a median that's 3 higher than Sydney. So Sydney's average was only about 1.5 higher, but Rachel's median is 3 higher. So why does that happen? How can two measures of central tendency give different results? Like the mean is saying that Sydney's better, but the median is saying that Rachel's better. All right, well, hopefully you notice this guy right here. This is an outlier. All right, Rachel had a bad day on test day, one of these 6 tests, and she got a 56. If you take out that 56 and you look at all of the other values, the other 5 values, they're all in the 80s. They're all above 85. These are really good scores here. That 56 is an outlier, and it dragged her average down. So, and this is really how it works in school. It works both ways. If you had bad test scores all year, but you do really great on the final, that can bring your grade up a ton. And if you let it slip one test, one unit out of the year, and you don't study and you're not ready for it and you get a bad grade, it can really make a difference. So you can see she has 5 scores that are above 85, but her average is still not above 85 because of that 56. So you could make the argument that Sydney is the better student because she's more consistent. She doesn't have those really low test scores. But you could also make the argument that Rachel is the better student. She just had one bad day. Other than that, her median score is an 88, which is much higher than anything that Sydney's got going on here. So that's the cool thing about statistics. Both of these girls could make a valid argument that they are the better student. And it's really up to just who can argue it better, who makes more sense. It's kind of like a lawyer doing his thing in court. Both sides may have a perfectly valid case, but whoever argues it better and uses better statistics and stuff like that is going to win out that case. So there's some really interesting stuff you can get into when you get into higher statistics classes and stuff like that. All right, people, appreciate you hanging in there with me. We are almost done here, and then you're going to get a chance to get some help on the application, and then get to do the rest on your own and turn it in. So on the second page, we just have a couple more examples here, different real-world applications where it's helpful. It could be helpful to collect the data set and learn something about the data by finding the measures of central tendency. So again, here's a little bit more about outliers. I'm not going to read the entire thing to you, but because we already kind of talked about it in this video. Basically, the big takeaway here is the best measure of central tendency. Like, what is it, and when should we use mean? When should we use median? So what you need to know is If there are outliers present, the median is usually the best way to go because the median is unaffected by those outliers. Remember, outliers can really drag the mean one way or another where it really shouldn't be. So outliers have that effect on them. So if there are no outliers present, the mean is usually the best method to describe the center of the data. But if there are outliers present, then you should use the median. All right. So, and it's just kind of a gut shot call on if there are outliers or not. You kind of just know it when you see it. So let's look at some examples here. All right, first one, Mercy High School golf scores at a tournament. So you can see we got the data there. The first thing I always do is put them in order. All right, put them in order from least to greatest. Sometimes I cross them out as I write them just so I don't count one twice or so I don't skip one. Okay, but that's important to put them in order. That helps you find the median. So you're going to have to do it anyway. So you might as well go ahead and do it right off the bat. So to calculate the mean, we just, remember, I'm not going to show you the math. You know how to do this by now. You know how to use a calculator. But we add those all up. We divide by how many there are. So if we count them up, we got 1, 2, 3, 4, 5, 6, 7, 8. So we add all 8 of these numbers up, divide by 8. That's what we get. What's the median? All right, so we're looking at the middle two numbers, which would be 91 and 93. And we know you can kind of do this in your head. Or you can just add them up and divide by 2 if you want. But the number that's right between 91 and 93 is 92. All right, so look how close the mean and the median are. And the reason that they're so close, there are no outliers. The range is very small, and there's no really low scores and there's no really high scores. So that's why they're so close. All right, so that's really the big takeaway, is that you understand the difference between mean and median, why they're close sometimes, why they're far away sometimes. It all has to do with the outliers and really the range. So that's a small range. All the scores are within 18 shots of one another. The mode is 84 because we have two 84s and no other value repeats. Okay, so what's the best one? In this case, they're basically the same number. 91.9 and 92 are, you can flip a coin. They are interchangeable. All right, number 2 is a little bit different. Number of students in Mr. Schaub's class. So this is real data. This is from last year, but this is real data. I had 11 students in one class, 12. The 45 was the study hall that I proctored, so I threw that in there. 13, 13, and 15. So do you see an outlier in this set? Of course, all the numbers are between 11 and 15 except for that 45. So that 45 is a huge outlier. So we can expect that the mean and the median are going to be pretty different on this one. So let's take a look at those numbers. The mean is 18.2. So right away, we're thinking, whoa, that number does not make sense. That's not the center of Mr. Schaub's data. Like, he doesn't normally have 18 students in his class. He normally has between 11 and 15. So again, that number is so high because of the 45. So we want to use the median. The mode is also 13, and then the range is 34. A high range means you probably have an outlier somewhere. So we want to use the median in this case because the outlier, it skews or it pulls the mean somewhere it shouldn't be, and that's what skews means. All right, so you try 3 and 4. And we'll come back, pause the video. I'll show you the answers. We'll talk about it. So ready, go, pause the video, try them out on your own. Okay, and we're back. So number 3, looking through these data values, I put them in order here. There's no real outliers, so they should be pretty close. They are. Mean answers the questions better, like what's the high temperature for the week? What was the average high temperature? That's the one you want to go with. Usually, if they're close, we like to go with the mean, just because it's the average. It does take every value into account rather than the median where we're just looking at the middle. Okay, so this is a better measure there. Remember, mean is usually better. If they're the same, then it doesn't really matter, but mean is usually better unless there are outliers. So again, number 4, this is where mode comes in handy, and I told you we'd come back to this. Mode, so if I give out a teacher evaluation to my students and I get ratings here, the average, even though you can see they're all pretty close here, the average of all these ratings is not really what I'm looking for. When I get those evals back, I'm looking at what most students are saying about me. So whatever is the most frequent, that's probably the one I want to look at in this situation. Remember, it always differs. It always varies based on the situation. So do I want to know the average score that I get on my evals? Sure, that gives me a little bit of information. But what I really want to know is what do most students think about me? Because that's probably the best way to tell how I'm doing in the class. So I'm going to look at those 4s and think, okay, I'm doing pretty good. I could do a little bit better. Okay, so like I said, ooh, you can do 2 of them. Sword fight. Ching, ching. Okay, anyway, getting distracted. So yeah, 5A and 5B, I just want you to try these on your own. Find the mean, median, mode, and range, and then tell me what the best measure is. And let's take a look at the application. I'll get you started on this just so you know how to follow the directions. The rest of the stuff you should be able to do on your own. It can be a little bit tricky, but that's the point, all right? I want you to struggle a little bit so that you can overcome that struggle. Come to the Zoom session on Tuesday. Ask questions whenever you need to. Wednesday I'm in office hours. Friday I'm in office hours. All right, let's take a look at this. Your application is a riddle worksheet, and the directions say, write the letter of the exercise in the box that contains the number of the answer. All right, and some answers are rounded. So remember, you got to look for the right number. If you can't find it, round it a little bit differently. Look for that number. Okay, we can do it, and we're trying to answer the question, what did the boy bumper car say to the girl bumper car? So remember, if you do it right, down here at the bottom, you'll figure out the answer to that riddle. It should make sense. If it's not, then you got a couple mistakes that you got to fix. Okay, so it's a self-checking worksheet. You should be able to know if you're doing it right or not. And like I said, ask questions, get help, ask a classmate, whatever, parent, brother, whatever you got to do. I'm always available to help you too. So number 1, the table shows the lengths of 8 canoes sold last week by the Canyon Canoe Company. Find the following. Okay, the mean length of the canoes sold. So here's our data, right? We got 8 values in our data, so we're going to add those all up and we're going to divide by 8. We're going to divide by how many there are. And that gives me a grand total of 16 feet. All right, so 16 feet is our answer here. All right, that means this is, and I always like to do this. All right, so by 16 feet, I'm going to write an E because that's the letter of the exercise. So that tells me I'm going to put an E in box 17. All right, so we throw that in there, and we're good to move on. Remember, let's do median. We'll do median, and then that's it. I think you can do the rest of them. But remember, median, we got to put them in order. So 13, there's 2 15s on there. Remember, it's a good idea to cross them out as you do them just so you don't miss anything. 16, there's 3 17s. So I bet we know what the mode's going to be. All right, and so there we go. So what is the median? All right, so we got 1, 2, 3, 4, 5, 6, 7, 8. That's an even number, so we're going to have to take the middle 2. 16 plus 17 divided by 2 gives me 33 divided by 2, which is 16.5. All right, so for 16.5, I'll put that here. 16.5 feet, and this is going to be a V, so a V in box 9. All right, and you just have to keep going with that. That's how you do it. Make sure they do get tricky. You can see there's some bar graphs down here. And then part 4 will make you think. All right, so take your time, think about that. And definitely in the Zoom session tomorrow, I'd be happy to do all of these problems with you. So come to the Zoom session. If you can't make it, then definitely watch the video recording of it to get some help with these. These are going to be tricky, but you can do it. All right, you guys have been doing an awesome job this whole time. We got 2 more weeks, so let's finish strong. Remember, I'm going to be grading these for correctness and for work shown. All right, you are not going to be tested on this, so I'm going to be looking to see that you did all of this right. All right, so take control of your own learning. Get help when you need it. Use all the resources that are available to you. Keep working hard. You're doing a great job. I am out. I will be talking to you this week. Have a great week, everybody.